Hey scholars, today we will learn about the principle of stratigraphy. What you will learn today? Today you will learn about the principle of stratigraphy, the different positions of rock layers, and the method used to find out the age of rock layers. Before we begin, let's activate some prior knowledge. Take 1 minute and use your observation to describe 2 things that you see in this image. Pause the video if you need extra time. First and foremost, as you can see in this image, all the rocks above this line here are similar. And as you move down, you will see that the stratas in the bottom also look the same and different from the layers above. And as you move down, the layers from the bottom will continue to look different. And as you can see, all the layers are positioned horizontally. So what is the principle of stratigraphy? The principle of stratigraphy is the study of strata and their relationship. A strata is a rock layer, and rock layers are always positioned horizontally, with the strata in the bottom being the oldest, and the strata in the top being the youngest. Geologists who study stratigraphies are always interested in learning about the position of strata and their relationship with the geological past. Stratigraphy has helped humans investigate major events in history, such as mass extinction, natural disaster, natural hazards, and early formation of the Earth and the solar system. A rock is a naturally occurring solid made up of minerals. Earth history is recorded in rocks and is written in the language of rocks. And who was the first person to learn and study the language of rocks? Nicolaus Steno was the first person to investigate and learn and study the language of rocks. Nicolaus Steno was born in 1638 in Denmark. He was a Danish scientist who studied anatomy and geology. In 1660, he left Denmark and moved to Florence, Italy to study medicine. In medical school, Nicolaus Steno studied anatomy. When Steno traveled to Tuscany, Italy, he saw caves, he saw mines, huge mountains, and coastal lowlands. After this experience, he studied sharks, and he noticed that a shark's teeth resemble objects found in rocks formation. His observation on shark teeth and rock layers allows Steno to formulate 4 major principles of stratigraphy. And those principles of stratigraphy are still used today. Those principles of stratigraphy are the law of superposition, the law of original horizontality, the law of cross-cutting relationship, and the law of lateral continuity. First, we will study the law of superposition. And what is the law of superposition? The law of superposition states that the younger rock is always on top, and the oldest rock is always in the bottom as a result of gravity. The younger strata always sit in the top of the oldest strata. Gravity is the force that attracts 2 bodies together and causes objects to fall towards the ground. For example, this image here shows 3 different events in history. Strata A shows an event in history where fossils of fish are found. Strata B and C shows 2 different times in history. Strata B shows a species of arthropod or insects. And strata C as you can see here, shows another species of arthropod known as trilobites. Each fossil represents a different time, era, and period in the geological time. A fossil is a preserved remain and remnant of the geological past. Rock and fossils can help us determine the order of events in strata. The next law of stratigraphy is the law of original horizontality. And what is the law of original horizontality? The principle of original horizontality states that layers of sediments of strata will remain in a horizontal position under the action of gravity. These layers will remain undisturbed if no deformation occurred. As you can see here in the bottom, these strata here have the same position as when it was first deposited. A sediment is a solid material of rock that is moved and deposited in a different location. Next is the law of cross-cutting relationship. And what is the law of cross-cutting relationship? The law of cross-cutting relationship states that an intrusion that cuts into an older layer is younger and continues to be younger than the layer that it cuts. Intrusion is something that injects or intrudes. For instance, in this image, we can see different layers of strata. Next, let's imagine that we have a 6.9 magnitude earthquake, and the magnitude earthquake creates a motion that moves this entire layer. The earthquake movement causes one layer of strata to intrude or inject into other layers. After the intrusion occurred, you will have a layer that cuts into other layer, and the layer that cuts off will always be younger than the other layer here. Next, we have the law of lateral continuity. The law of lateral continuity states that strata that are separated extend sideways for some distance. As you can see in this image here, you can see two hills. But even though they were separated for some reason, the layers still remain the same. For instance, in this image, you can see two layers that have been separated in the past. Although both regions have been separated in different directions, their strata layers will always remain the same, as you can see here. These are rock layers that have been separated by many reasons, perhaps a volcanic eruption, or an earthquake, or an asteroid impact, or any other natural hazard. Now that we have learned about the principle of stratigraphy, let's memorize each of them. Take 2 minutes and study this principle of stratigraphy. Pause the video if you need extra time. So now that we learn about the principle of stratigraphy, what methods are used to find out the age of stratigraphy? So two methods are used to find out the age of stratigraphy: relative dating and absolute dating. Relative dating determines the years of the geological timescale by using non-numerical comparison of strata or rocks and fossils based on their features. Relative dating determines the age. Relative dating determines the years of the geological time by using non-numerical comparison of strata and fossils based on its features. We can put events in order based on their relative age. For example, dinosaurs lived before humans because their fossils are found in lower layers of rocks and never in the same layer. Absolute dating. Absolute dating determines the years of geological time using numerical values. Absolute dating uses radioactivity of isotopes to determine the age in years. For example, the layers of the strata from the Precambrian Eon shows that the Earth was formed 4.6 billion years ago. Now that we've complete our lesson for the day, take 2 minutes and answer this question. Remember to pause if you need extra time.